We have seen these self-healing materials in sci-fi films for decades. But now, they are no longer only for the silver screen. Scientists have managed to develop self-healing materials in a mixture of environments. Imagine you break your phone screen during a night out, yet you wake up to find it as good as new. This is the stuff of tech dreamers everywhere. This is Materials Lab, self-healing materials. Self-healing materials are considered to fall under these four types. Materials with embedded healing agents, materials with a kind of internal vascular circulation, shape memory materials, and reversible polymers. Embedded healing agents have built-in microcapsules filled with a glue-like chemical that can repair the damage. If the material cracks inside, the capsules break open. Unfortunately, the capsules have to be so small that they weaken the material they embed, and this limits the amount of damage they can fix. These capsules can only work once, and the material cannot heal itself twice.
柔らかいと直しやすいんですけど、もう硬いもの、変形しにくいもの、強いものにしていくに従って、治る性質も同時になくなっちゃうというのがあったんですけど、そこがバランスできるポイントってのをうまく見つけて。
Microvascular materials have networks of extremely thin vascular tubes built into them that can pump healing agents to the spot of damage. The drawback is that the healing agent could travel slower than the damage spreads. Shape memory materials flex back into their original shape after being bent and released. Then we have reversible polymers. Thermoplastics have been designed so if they are cracked or damaged and then heated, the polymers will break down into their monomers. This method does rely on having a supply of heat nearby. Tests have been conducted by firing bullets at the materials. The heat from the impact effectively lets the polymer reseal the hole and bind the material together again. Now, these four ways of having self-healing materials were the standard approaches. Until early 2022, when scientists developed an eco-friendly, self-healing nanocrystal semiconductor. In particular, the category called double perovskites, toxic-free alternatives to commonly used lead halide perovskites. Researchers at the University of Illinois have developed a self-healing electrode. The electrode causes a reaction in the microcapsules and disperses throughout the crack-filling materials to make the battery safe. And finally, when you have to attend the hospital and are given a 24-hour monitor to check for any irregularities, it's common for these devices to be damaged by daily use, which impacts their functionality. Researchers have been developing a flexible, nanoparticle-based sensor with self-healing properties. Imagine if our clothes would automatically repair after being torn. Melik Demirel describes a liquid that can mend clothes. The team used bacteria and yeast to create a biodegradable liquid material that can help fabric quickly bind to itself. It's hoped that the liquid could be poured into a washing machine like a detergent, and the magic would happen. According to Melik C. Demirel, the coatings are thin, less than a micron, so they wouldn't be noticed in everyday wear, said Demirel. Even thin, they increase the overall strength of the material. So, it might not appear that we are going to have the extreme functions we have seen for years in the cinema, but it's clear that we are on the right path. We only have one foot in the door of self-healing materials. Imagine what the future holds. With continued development of self-healing materials into modern-day applications. In the short term, we may not have to worry about our phone screens ever again, and in the long term, we may get those robots similar to Terminators that can liquefy and relocate themselves.